Hello everyone and welcome to a tutorial on setting up a mutual TLS authentication with Nginx Proxy Manager. So just to start, I think I need to explain what is actually the mTLS. So here I have a Wikipedia article on it, and it basically tells us that mTLS is a way to authenticate not only the server but also the client of a TLS connection. So let's take an example when you want to access your local area network, your LAN, when you are not home. So you could set up a VPN, and that would be probably the best option for you. I really recommend it. WireGuard is a lightweight VPN protocol that's really secure, really fast, and relatively easy to set up. But today we are gonna do something different. And for me, it's mainly motivated by the fact that WireGuard has to be installed on the client device, it has to be activated manually, and it's not the most convenient way, especially for non-tech people that don't really understand what is a VPN and how to turn it on your device. So basically what we are gonna do today is to expose the Nginx Proxy Manager to the internet over HTTPS, and with the help of Nginx Proxy Manager we can actually expose also our services that are running in our local network. But just doing that is strongly discouraged. Just think about it. You of course can have some services with passwords and stuff, but when you're exposing HTTPS to the world on your public IP, you don't really have any control over who can access it. Using mTLS actually prevents clients that don't have a valid certificate to access your service. So let's actually start doing stuff. As you can see here, I have my super important service that's running in my local network. So it's running on this server, and I would want to expose it over the internet, but that way only the clients I choose can have access to it. So for example, it can be myself or my family, whoever has the valid certificate. We will start by just copying this Docker Compose file for Nginx Proxy Manager, and I will create a directory which will be holding the data of Nginx Proxy Manager as well as Docker Compose. Now I will create the file called dockercompose.yml and leave everything as it is here. Now you have to have Docker installed on your server, so I will not show you how to install Docker. There are so many great video tutorials on it, but if you just want to know if you have Docker installed and running properly, I recommend you running docker ps, and if you see this stuff, that means your Docker is installed correctly and you have access to it. Now we will start a container with Nginx Proxy Manager. It will actually pull the relevant data and containers. I've actually got an error here saying that the port 80 is busy because on the same machine I'm also running this Nginx super important web server. So give me a moment, I will just change the port for Nginx. And of course, if you have anything running on port 80 or 443 on your server that you are installing Nginx Proxy Manager, you should change that, because only Nginx Proxy Manager will have access to these two ports. So I'm actually changing this port to 8080. Which is HTTP alt, and it will not collide with our Nginx Proxy Manager instance, so that's fine. But now we have to access our server with port 8080. Let's try starting up our container again. Now I will do the initial configuration of Nginx Proxy Manager. So I will type the address, or in this case domain name of my server, and the port to configure Nginx Proxy Manager is 81. And I think the default credentials are admin@example.com and password is changeme. So now we can actually set up our email and user. And now the password. So once again, changeme is the current password. And the new password, I will just type mTLS is awesome, but you should pick a stronger password, of course, because Nginx Proxy Manager is actually facing the internet, so it's really high risk service. You shouldn't keep the default password. And my user is created successfully. Now what I will do is to go to hosts, proxy hosts, and add proxy host. Here you have to type your domain name. So I would recommend you getting a DNS, dynamic DNS domain, because it's free and you can run a daemon that would automatically update your DNS record whenever your IP changes. So for example, if you have a dynamic IP, you run a client in your local network that checks the IP and sends it to DNS, and it's free, so I would really recommend you setting it up. I already have my domain name, so I will just type it in here. So it's mTLS is awesome.dns.org. And here you have to type the IP or host name of the service that you want to expose to the internet. So in my case it will be the mTLS demo.lan port 8080. I would recommend you check the blog common exploits and WebSockets support, because many web apps use WebSockets today. Now you have to go to the SSL tab and request a new Let's Encrypt certificate. Here I would recommend to check the HTTP2 support, because it's faster than the older HTTP 1.1, and also force SSL. You have to type your real email address. You will get notifications whenever something goes wrong with Let's Encrypt. And you also have to agree to the terms of Let's Encrypt. But before you click save, you have to open ports on your router. So Nginx needs port 443 and 80 to be opened. Here I have my OpenWRT router that's actually running on a Raspberry Pi 4. And in OpenWRT, you have to go to Network, Firewall, and Port Forwards. Of course, if you're using something different than OpenWRT as your firewall, you would need to do it differently. So here I'm gonna click Add. I will name this forward Nginx Proxy Manager HTTP. External port should be 80. Destination zone LAN, so your local area network. Here choose the IP address of your server that's running the Nginx Proxy Manager, and internal port will also be 80. Click Save and do the same for HTTPS, except port will be of course 443. Okay, so now click Save and Apply. And now you should be good to go. So here you can click Save. If everything is fine, you should see the proxy host that's online. You can also check if you can access your service via the internet. As you can see, we have a valid HTTPS certificate and our domain is working. We have our super important stuff that we would not want anyone to see. But right now everyone can see it. So you should probably quickly disable this. And we will do some changes to Nginx configuration to enable client authentication. The first thing we'll do is to create new directory on our server, and this directory will store our certificates. Now I will use these two awesome guides on GitHub that show how to create client-side SSL certificates. So this one is more up-to-date, but it uses RSA, and the thing with RSA is it has really long certificates, and in the original version of this tutorial you actually had an option to choose elliptic curves. You also could use AES 256, which is more secure than -3. So I will create the certificate authority root using elliptic curves. Okay, if everything is okay, you should see one file created here. And now to actually generate the certificate root, we have to issue this command. Right now we only have the key for the CA authority root. And so here you will be asked a couple of questions like country name. If you are just gonna use this for your HomeLab, you don't have to type any like true informations here. Okay, so now we have our root certificate authority created. It will be valid for 10 years actually. You can change it, of course. That's just how long this certificate will be valid. And now we will create the client key. So it will be the key for the client accessing your server, of course, and you can enter the name of your client here. I will say smartphone. Okay, it got generated successfully. I see OpenSSL is telling us that we should use this name, and this is probably because the guide is not updated. So maybe you should replace the secp 256R1 with V1. I don't know, maybe, but this works just fine. And now we'll generate the client CSR. You also have to type some details here, but the only important thing here is the common name. And it should be the same as your key name, just for convenience. Here you also have to fill in the challenge password. It will be asked when installing that certificate on a client device. Oh, it shouldn't be more than 20 bytes long, so maybe you should use a randomly generated password, not like me. Now you have 4 files, so the certificate root key and actually the certificate of certificate authority, the CSR of client and the client key. So the last step right now will be to actually create the client certificate and sign it with the CA root authority. Here you have to change the CSR as the in parameter to the CSR of your client. Maybe change the days, so this certificate will expire after a year. And the very important argument is also here. So set serial. I'm gonna stick with 01, but if you had more clients, you would just increment this value for each one. So 02, 03, and we want to get this certificate into smartphone.crt file. Oh, sorry, we got an error because we don't have ca.crt, we have ca.pem. Right now it works. Sorry about it. I got confused. Right now we need to convert this client certificate into a format installable on client devices, so we'll export it into the P12 format. And this format is accepted by, for example, Firefox and Android. However, we will do something different than described here, because generating the P12 bundle like this will actually work in Firefox and probably most other browsers, but not on modern Android versions. So there's an issue in Android that will tell you that you entered the wrong password, and it will just refuse to install the certificate. There are some resolutions to this. For example, we can use the legacy flag when exporting into P12, but legacy actually uses RC2, CBC, and FreeDES CBC. So your certificate is downgraded from FreeDES CBC and AES 256 into this, and I wouldn't trust it, honestly, because RC2 is a standard that was designed around 1987, and it actually uses, I think, only 40 bits, yes, 40 bits for key. So for a modern computer it would be like a day of brute forcing your certificate to just extract the key, for example. I would not recommend you using the legacy flag. Instead, what we'll do is to just install GnuTLS certtool, and in it we can actually specify the hash and cipher used for our certificate, because OpenSSL, as far as I know, doesn't let you do that. By the way, here is a really nice table done by the user Limilo, I think, sorry for the pronunciation, and he actually tested the Android versions that accepted the certificates in different formats. As you can see, Android doesn't support certificates that are using AES 256, neither the longer SHA versions, and as you can see here, it seems like Android actually downgraded. So it used to support SHA 256, which isn't broken, but in Android 12 you can only use SHA 1, which has been broken for a couple of years now. Anyway, here you can just install GnuTLS-bin, and you have certtool installed. So right now I will just substitute everything here. I'm not sure if the password I should type the same I gave to the certificate. I will check that. Okay, so maybe actually you can have different password for the certificate and for the CSR. But I used to generate my certificate using the same passwords, so I will do that here also. And I will use the password I gave earlier. Okay. And as you can see, we have a smartphone.p12 file. You need to somehow transfer this file to the client and install it there. Actually, the last thing to do is to configure Nginx in Nginx Proxy Manager to use our client certificates. So first thing we need to do is to share the ca.pem file with Nginx Proxy Manager. So I will just mount this single file in our container, and I will bind it to this directory in my container. Right now the only thing left to do is to restart the container and edit the configuration as did the user DM Wilson 1990. So I will copy that, and we go to Nginx Proxy Manager, and here we click Edit, Advanced, and our custom configuration. And here will be the file that we just mounted to the container. Now we click Save, and we can enable our host. Right now, if you go to this domain, we've got 400 bad request, no required SSL certificate was sent. So if I were some bot on the internet, I would just see that. Okay, so right now I'll show you how to install the client certificate in our browser on Linux. I don't know how it will work on Windows, but if you get it working, please let me know in the comments. So I'm actually using a Chromium based browser. Right now I will go to Settings, search for Certificates, Manage Device Certificates, and import in your certificates. And here I have this certificate which I imported from my server. I have to provide the password. It's actually my smartphone's certificate, but I don't want to create yet another one. Okay, and as you can see, we have these org mTLS company clients and smartphone. Right now, we can refresh the page, select the certificate, click OK, and we are in. Okay, so right now I'm on my smartphone, and as you can see here, I'm also getting this bad request error, even if I have a different IP address on this smartphone. So, in order to install the certificate, we have to transfer it to the smartphone, of course. But once it's transferred, you can actually just click on it, wait a bit, and enter your password. mTLS underscore smartphone in my example, and click OK, and wait a bit. Okay, and the type of certificate is a VPN and app user certificate. Click OK. Name, I will leave that as smartphone. And as you can see, the certificate is now installed. I can refresh the page, and hopefully, yeah, as you can see, it's asking me for the certificate. And we've got access to our super important personal stuff. So, we've got our certificate working on Android. And I know there's a Home Assistant that is supporting these client certificates, but it really depends on the app. For example, Nextcloud doesn't support them, because implementing such support on Android isn't really the easiest thing to do. But in the browsers, it works fairly well, so If you have some service that you are accessing through your browser, you should be perfectly fine. And if you have some app for your service that you're hosting in your home, you have to look for the client certificates and how to import them in your app. And there's one thing that I skipped. DM Wilson is actually comparing the certificate common name with this string, and that can be useful, for example, when restricting your access to some devices. So you could do something like regex matching, as you can see here, and you can, for example, start your common name for the clients with some prefix or suffix, and this way you can really control what devices can access certain services. So I think that's it for this video. Sorry if it was long and boring, but I hope you learned something and maybe it will be useful for you. So thank you all for watching. Thank you for sticking with this tutorial, and I hope I will see you soon.